All right, here we want to look at one of the practice example tests to get ready for our derivative mastery test, where we just prove that we know how to do the mechanics of derivatives. So power rule, product rule, chain rule, and kind of mixing them all together. So number one is take the derivative of 5x to the third plus square root of x plus 1 over 2x to the fourth minus x squared plus 31x plus pi. All right, so very first thing, if something isn't already written in terms of a power, it makes it way easier to do power rule if we rewrite it. So x, square root of x is the same as x to the 1/2. X to the fourth in the denominator is the same as x to the -4. Be careful that doesn't change the front number. This is still 1/2 times 1 over x to the fourth. And everything else looks pretty ready to go. And so now I can take the derivative of everything. So 5x to the third is 15x squared. X to the 1/2 is 1/2 x to the -1/2. So don't forget we're subtracting 1 off the exponent. When I multiply this out front, -4 times 1/2 is -2. And since we're subtracting 1, it'll be to the -5th. Derivative of -x squared is -2x. Derivative of 31x to the first is 31. X to the 0, so 31 times 1. And pi, don't forget, is a constant, so derivative of a constant is 0. And so we're essentially done, but we don't want to leave like negative exponents. You can put this as 1 over 2x to the 1/2, or you can put it back to square root. Either one is fine. The negative means it's in the denominator. And these ones are about as cleaned up as they're going to be. So number one, this would be a great simplified equation we started with. All right, number 7 goes back to just taking the derivative of individual terms. So the first thing I want to do is rewrite it. Way easier to see power rule if you have them all written as something to a power. So that in the denominator means that it's -7, or it just helps avoid sign errors, which is the main thing that probably happens on a problem like this. So I rewrite them all as negative exponents. And so now I can take the derivative. So this is -28, right? -7 times 4, x to the -8. Negative times a negative is +6, x to the -3. And then this is -1, x to the -2. And so we're done. We could maybe make it look a little bit nicer by putting our negative exponents back on the denominator, since a negative exponent means the reciprocal. And you can put plus -1, or you can put your minus here. It doesn't make a difference. Sometimes I like to put it up top. It just makes it, emphasizes it more so it doesn't blend into the rest of the problem. But totally up to you. This